I'm an emergency manager and former first responder. Let's talk about why fire burns faster up hills. So in reference to the LA fires, I'm seeing a lot of questions or comments about like, I didn't know that fire burnt faster uphill. But let's talk about the science behind it. We're gonna use some fire because it's a good demonstration and we're not gonna burn fingers today. So I've got my matchstick and this is my fuel. So if you think about the fire triangle, what does fire need? Heat, oxygen, and fuel, right? So I have the fuel here, which is the matchstick. I've got oxygen in the air, which is just the atmosphere in general. And now I'm gonna add some heat to it, which is my candle. That's my heat source. So I've got all three, I've got fire burning. Now, if this was my landscape, like my matchstick was my landscape, the fire is just gonna burn through the fuel. It's gonna burn whatever it has in front of it. If I give it a little bit more oxygen, not too much, it will burn a little bit faster because that's more to its triangle. Now, if my terrain is a mountain, an uphill, look at how much faster this is burning because the flame is closer to the fuel. So it doesn't have to travel as far to burn. It's heating up that next fuel faster. It's got access to it. There's less distance it has to cover to get to that fuel. So it doesn't have to push its heat nearly as far. It's just convenient. If the fuel is closer, the fire will burn it, right? So in the case of the LA fires, when they're on mountains like this, plus they've got a wind event blowing uphill, which of course I'm talking on this fire, it's gonna burn up that hill faster. Does that mean that fire doesn't burn downhill? No, not at all. Fire burns whatever fuel it has. Whatever fuel is around, anything that's flammable, it will burn. Let me put out my small fire here. We're not setting off smoke alarms. So this is why you see when someone lights a match, a lot of times if they can't get it going, they'll go like this and push it up. Well, what are they doing? They're moving the fuel closer or more in front of the fire that's burning there. So in the case of my sink fire that I've lit here, look at how the fire is moving outwards and eating all of that fuel around it. It doesn't care what direction it's in, it's just eating the fuel. Now, in the case of LA, contribute a wind. That's making those flame lengths even taller. It's pushing the fire up. It's feeding it more oxygen, and now you've got fire moving uphill. Those flame lengths are even taller because the wind, the fire is being pushed by the wind, and now it's even closer to more terrain. So those fires are just ripe to be ripping the way that they are, and that's what makes them so hard to fight, is they're aggressive fires, they're big fires, they've got a lot of dry fuel to eat, they've got a lot of oxygen blowing on them, and they are building up huge sources of heat. So they look like these huge monstrous fires. And in the case of the Hughes fire, it's burning so quickly and it's expanding very, very